Kia ora Year 12. This is question 11 from the exercise on DEs for Ethan. It's a 4-part question and it's a really good one. So it's always worth going through all 4 parts before you start. The first bit is a straightforward integration by parts problem. So we have to integrate that. Then you know that we're going to use that result in the next bit. So we have to show that this integral is equal to this one. Now the tricky thing straight away in here is the cos squared x. When we see that, we want to be using the double angle identities to help us, and that fits with what we did back up here. So there's a little bit of work to change this integral around before we start integrating. Okay, next we have to solve this DE, and you can see that that's going to involve separating the variables, and we're given an initial condition. So that doesn't look too bad, especially because we've just integrated it up in this question here. And I'm going to come back to question 4 when we get to it, right? So we've got some kind of condition that we're putting on, well, we're looking at just some of the solutions to the DE, and we're showing that if those solutions are true, then this must also be true. Right, so let's start by looking at how we integrate 4x cos of 2x. So this is a very easy integration by parts question. We need to choose one bit to integrate both times, and that's going to be the trig bit, and then this bit we're either going to leave or differentiate. So here we're going to have 4x times, now when we integrate cos of 2x, we'll have half sine of 2x minus the integral of 4, right, that's coming from differentiating the 4x, times 1/2 sine of 2x dx. Right, now cleaning all of that up, what do we get? Well, we get 2x sine 2x minus the integral of 2 sine 2x dx. Now think about where this came from. Cos of 2x will differentiate to give me negative 2 sine 2x, which is exactly what I want. So this has come from plus cos of 2x, and don't forget the plus c, right? You've got an indefinite integral there. So that's the first bit done. Right, now the next thing we need to do is we're going to be integrating this, and we have to show that we're going to end up with this, and you can see a whole lot of stuff matching up to the thing we've just done. But we have to fix up the cos squared of x, right? We can't integrate cos squared of x easily as a power. What would make that much better, but it doesn't help us here, is if we had sine x cos squared of x dx, or some multiple of sine x, we'd be fine, right? Because it would be a chain rule, so it would be something with a cos cubed of x, but it's not. So we're going to use the double angle identity, and we're going to use we're going to change the cos squared x into something to do with cos of 2x. So cos of 2x is equal to 2 cos squared x minus 1. That gives me cos of 2x plus 1 divided by 2 is equal to cos squared x. So that's 1/2 cos of 2x plus 1/2. So if we just park that and do that off to the side, we're ready now to do the big integral. We've got 8x cos squared x dx is equal to 8x times 1/2 cos 2x plus 1/2 dx. So that is equal to 4x cos 2x plus 4x dx. This is what we integrated just before. So we can go straight to what we found, which is 2x sine 2x plus cos 2x plus the integral of 4x is 2x squared plus c. And that's exactly what we're after, except not in exactly the right order. So I'll just rewrite it as as they asked us to. Okay, so that's the first two bits done. Now, the next thing we had to do in this question was to solve a DE. So let's just, hopefully you've got your textbook in front of you. Find the solution of this DE which satisfies y equals root 3 when x equals 0. Okay, so we're going to separate the variables and then we'll substitute some things into it. Let's see, we've got dy by dx is equal to 8x cos squared x divided by y. Separating the variables gives me y dy equals 8x cos squared x dx, and we'll integrate. Integrating the left-hand side gives me 1/2 y squared, and we know what we're going to get here because that's what we just did in part B. So this is 2x squared plus 2x times sine of 2x plus cos of 2x plus c. And we're going to use the point 0 root 3 to figure out the value of the constant. So let's substitute that in. Right, so we get 1/2 times 3 is equal to 0 plus 0 plus, now cos of 2 times 0 is 1 plus c. So we've got 3 over 2 is equal to 1 plus c. c is equal to 1/2. Okay, so now usually when you're solving a DE, you're going to end up getting y equals something, but in this case we don't have to do that. Right, we're just going to write this differential equation. I'm just going to change the pen to make it sparkly and nicer, because grey is very boring. Just a sec. Okay, so what have we got here? Well, we've got 1/2 y squared is equal to 2x squared plus 2x sine 2x plus cos of 2x plus 1/2. What am I going to do here? Well, I'm going to get rid of the half because that's just horrible. So we're going to have y squared is equal to 4x squared. So I'm multiplying everything through by 2 now. Right, so I'm going to leave it like that. I could do a positive or negative root, but that feels fine. And that's going to help me when I get to part 4. Because what I've got to do for this last bit is to show that any point on the graph of this solution which satisfies sine of 2x equals 1 also lies on one of these two lines. So we're going to go back to that solution and we're going to substitute in this and think about what that means. Okay, looking at, just let me shrink my screen. Right, so look what we've got down here. Well, we know that the condition we're putting on is sine of 2x equals 1. And if you're in my class, you know what I'm going to tell you to do now. And that's to draw the graph. Because here we've got sine of 2x, but here we've got cos of 2x. So what's going on here? Well, here's my curve. If sine of 2x is equal to 1, what's happening with cos of 2x? I really should have drawn this before. There's my stylus is doing something weird, right? But you can see that when sine of 2x is equal to 1, cos of 2x is equal to 0. And we need to explain that, right? So when sine of 2x equals 1, cos of 2x is equal to 0. So if we're imposing this condition, we're also putting on that one. Substituting in now, we get y squared is equal to 4x squared plus 4x plus 1. And that's a perfect square. Y is equal to 2x, y squared is equal to 2x plus 1 squared. So I think this is a really nice question, right? So y is equal to either 2x plus 1 or the negative of 2x plus 1. So y is equal to 2x plus 1 or y is equal to the negative of 2x plus 1, which is negative 2x minus 1. As required. So there you go, quite a long question, really tests quite a lot of different algebraic skills. So there's a little bit of trig in there, there's separating the variables, integration by parts, and your double angle identity. That comes up all the time. Thanks for watching, have a great day, and email me if you've got any more questions you want done.